Hello everybody. Today I'm going to start a new series named Problem of the Week, and as its name suggests, I'm going to choose in each week an interesting problem which was given at one of the contests from that week, and I'm going to make a video tutorial for that task. For this week I've chosen the problem E, Complicated Computations, from the Codeforces Round 678 Division 2. The contest happened yesterday, so this will be the first problem of the week. In this task, we are given an array of n elements, and we need to find the max of maxes of all the non-empty subarrays. We are given the definition of max, which is the smallest positive integer not contained in the array. The word positive is bolded because usually max also includes 0. But we don't have any zeros in this problem, so it was clarified that we are going to use only positive numbers. Now, looking at the first glance, one would find a really easy n-squared solution, which is basically just computing the maxes for each subarray and then finding the max of the maxes. But even though n is only 100,000 and not a bigger number, it still doesn't work. The time limit is only 1 second, and n squared for 100,000 is obviously way too big. So we need to think of something smarter. Now, given that n is 100,000, it could have been 200,000 as well. My solution doesn't work differently no matter what. Maybe we can use like data structures to help us find the maxes. But in order to find the maxes, we need to obviously find some observations. Now, let's consider that we want to check if for some integer x, we can have max equal to x in that array. In order to have a subarray which has max x, we need to somehow have all the numbers from 1 up to x minus 1. It doesn't matter in which order they show up. It doesn't even matter if other numbers are between, as long as we don't have x somewhere in between. For example, if we have this array, so 1, 7, 4, 3, 5, 2, this subarray has max of 6 because we have all the integers from 1 to 5, and 7 doesn't matter for us since it's not going to affect our answer. But on the other hand, if we had something like this, 4, 2, 5, 6, 1, 3, 9, it could have been even 10, then this subarray doesn't have max equal to 6 because we have 6. It will be 7. So we need to be careful at such situations. Now, how can we find if there is a subarray which has max equal to a number x? Since I said that we can't iterate over all the subarrays and compute max manually, we need to think at a way to check if all the numbers from 1 all the way to x minus 1 actually show in the array without having a number equal to x in between. And the easiest way to do it, at least as far as I'm concerned, is iterating over numbers equal to x. So we can basically keep n lists with numbers and where they show up, since in the problem the numbers are from 1 to n. It's not necessary that they are a permutation, but there can be numbers which have equal value. It doesn't matter. So we're just going to keep n lists for each number, and if we are at the list number x, we need to consider two cases. If we don't have the number equal to x, so no x, this means that we have to stop the algorithm there and maybe check if we have this property, as in all the numbers from 1 to x minus 1. But if we reach this state where we break because we don't have any x, it means that we have that subarray because we found the numbers from 1 to x minus 1 before. But even when we are breaking at this stage of the algorithm, like when we don't find x, we need to be careful at one important corner case, namely if x is 1. If x is 1, then this means that we don't have any number equal to 1. So all of these subarrays will have max equal to 1. And the answer will be 2. Now, what happens if, on the other hand, all the elements from the array are equal to 1? Then the answer is 1, because for each subarray, the max is going to be 2. And when we are doing the max of the maxes, since we don't have any 1, then the answer is 1. So these are like the only two corner cases for this problem. Now, let's go back to the main idea. So we want to find if for some x, all the numbers from 1 to x minus 1 show up in a order such that we don't have any x in between. In order to do this, we can use a segment tree, which will tell us the last position for each number from 1 to x minus 1. And now the reasoning is quite simple. Let's say we have two numbers equal to x here and x here. As long as all the numbers from 1 to x minus 1 show up in this segment, then it doesn't matter if we have other numbers as well. This subarray is going to have max equal to x. And we are done with checking the property for x. So now all we have to do is to, as I said earlier, iterate over the numbers and check with a simple segment tree whether the minimum value among the last position for each number from 1 to x minus 1 is inside this box. And as I'm going to show you in the source code, it's not actually too hard to implement. So at first I checked if we have elements equal to 1 or 2 in order to deal with the corner cases. Then for each position, I did it slightly different, but you could have done it with like lists, as I said earlier. It doesn't really matter. It's just a slight modification. For each position from 1 to n, if the number is bigger than 2, then I check the property mentioned earlier in the drawing, like the box property. This can be done by querying a segment tree. These are standard segment tree operations, namely finding a minimum over a range and updating a number. This is pretty classical stuff. You can find it on almost every judge. And now, if the property is respected, then we check that we can have the max equal to vi. And now, obviously, we need to update the position vi, since we have a new last value, since we only care about where the last occurrence of that value happens. And obviously, at the end, we also need to check for all other numbers from 3 to n plus 1 if the entire subarray from that position on respects our property. We also need to consider those subarrays. Now, at the end, all we have to do is to check from 1 to n plus 2 if we found a subarray without max, and stop obviously at where the first max doesn't show up, because if it doesn't show up, then it's going to be the max of the entire maxes. I hope you enjoyed watching this video editorial, and as always, I want your suggestions in the comments and also on my Discord server, which will be in the description. And before we meet next time, good luck, have fun, and obviously stay healthy. Bye.